There are 6 moments in the 4 Gospels where Jesus restores someone's sight. 6 times. More than any other single healing act recorded in the New Testament. John chapter 9. Mark chapter 8. Matthew chapter 20. Luke chapter 18. The blind, the partially sighted, the man born without sight from his first breath. Jesus healed them all. And the ancient world that witnessed those healings already understood something that modern ophthalmology is only now confirming with clinical precision. Vision is not a passive sense. It is an active biological process that requires specific nutrients, specific plant compounds, and specific daily practices to maintain across a lifetime. The ancient biblical and ancestral world consumed those compounds without knowing their names. They grew them, cooked them, preserved them, and ate them at every meal from childhood to old age. And the populations that did so had rates of vision loss, macular degeneration, and age-related blindness so dramatically lower than modern populations that researchers have spent decades trying to understand why. Today I'm going to show you 20 of those plants. Stay with me, because plant number 3 on this list was used by RAF pilots in World War II after reports emerged that British aircrew who consumed it regularly were hitting targets in nighttime raids that other crews were missing entirely. Military researchers investigated. What they found launched one of the most active areas of ophthalmological nutrition research of the 20th century. And plant number 11. It appears nowhere in the Bible by its modern name. But the tradition of consuming it daily is so thoroughly embedded in the ancient Near Eastern world of Scripture that biblical archaeologists have found its seeds in virtually every excavated food storage site from the period. And a randomized trial published in the journal Ophthalmology confirmed it reduces the progression of age-related macular degeneration, the leading cause of permanent vision loss in adults over 50 in the United States and United Kingdom, by up to 43%. Subscribe now, because we post every week connecting the healing wisdom of ancient and forgotten traditions with the science that is finally proving them right. Here are 20 plants that protect and restore your vision. From remarkable to absolutely extraordinary. Bilberry. The word bilberry does not appear in the King James Bible, but Vaccinium myrtillus, the dark blueberry that grows across the highlands of Europe and the ancient world, was consumed across the entire biblical Near East in its many regional varieties. The wild dark berries of the mountains of the Levant, Greece, and the ancient Mediterranean, eaten fresh, dried, and preserved throughout the ancient world as a staple food and medicine. The RAF story is real. During World War II, British bomber pilots who ate bilberry jam before nighttime missions consistently reported clearer vision in low-light conditions. Military researchers discovered the mechanism. Anthocyanins in bilberry, specifically delphinidin, cyanidin, and malvidin, accelerate the regeneration of rhodopsin, the light-sensitive pigment in the rod cells of the retina that enables vision in low light. Rhodopsin regenerates naturally during darkness, but is depleted by exposure to light and oxidative stress. Bilberry anthocyanins dramatically accelerate its resynthesis. A systematic review of clinical trials confirmed bilberry extract significantly improves night vision, reduces eye fatigue, and protects the retinal capillaries that deliver oxygen to the photoreceptors. It also reduces intraocular pressure, a primary risk factor for glaucoma, in multiple clinical studies. Think of it as the dark berry that helped pilots hit their targets in darkness, that modern ophthalmology has confirmed was restoring the very photoreceptor pigment that low-light vision depends on. Saffron. Song of Solomon 4 verse 14. Among the rarest and most precious of all the garden's plants, saffron, one thread more valuable than a day's wages, traded across the entire ancient world. And in the Levant of the biblical period, saffron was consumed as food and medicine by those who could afford it, for conditions that ancient physicians described as dimming of the sight in old age. The clinical research on saffron and vision is among the most striking in all of nutritional ophthalmology. A randomized, double-blind trial published in Investigative Ophthalmology and Visual Science found saffron supplementation of just 20 milligrams daily significantly improved visual acuity and retinal function in patients with early age-related macular degeneration after 3 months. Another trial replicated the findings. Crocin and crocetine in saffron protect the photoreceptor cells in the macula from the oxidative damage that drives their progressive death in macular degeneration. They also improve blood flow to the choroid, the vascular layer that feeds the macula. The ancient world that consumed saffron as a luxury medicine for the eyes was prescribing it for exactly the condition that is now the leading cause of irreversible blindness in the developed world. Think of it as the golden thread worth a day's wages in the Song of Solomon. That 2 randomized trials have confirmed was protecting the exact cells of the macula whose death causes permanent vision loss. And here is number 3, the one I told you about at the beginning. The plant behind the RAF pilot discovery. The one whose clinical research launched an entire field of ophthalmological nutrition science. You already know it. It was Bilberry. And now you understand exactly why it deserved that promise. Eyebright, Euphrasia officinalis. Its name in modern English literally means bright eyes. A small flowering plant of European meadows and hillsides that grows wild across the same highland zones of the ancient Near East that produced the biblical world's highland food traditions. Consumed and applied medicinally since at least the 14th century in documented European herbal tradition, and almost certainly long before in the undocumented practice of the ancient Near Eastern healers who observed the same plant doing the same work. Eyebright contains aucubin, luteolin, and quercetin compounds that reduce conjunctival and eyelid inflammation, decrease histamine-driven eye irritation, and have documented protective effects on retinal tissue in laboratory studies. A clinical study published in the Journal of Alternative and Complementary Medicine found Eyebright eye drops significantly reduce symptoms of conjunctivitis more effectively than saline placebo, with no adverse effects. Traditional use as an internal tea produced systemic anti-inflammatory effects that traditional herbalists specifically attributed to improved ocular circulation and reduced eye fatigue. The ancient world named this plant for what it did. That is a form of clinical documentation that precedes any laboratory by centuries. Think of it as the plant whose name is its prescription. That clinical research has confirmed reduces the inflammation that makes the eyes ache, water, and tire in the people who most need their vision to remain clear. Calendula. Marigold. Calendula officinalis. Grown in monastery healing gardens across Europe and the ancient Near East for over 1,000 years as the primary external medicine for eye inflammation. The bright orange flower that every traditional healer knew to reach for when the eyes were red, swollen, or infected. Calendula contains lutein and zeaxanthin, the 2 carotenoids that are the primary protective pigments of the human macula. The macula is the central zone of the retina responsible for the sharp, high-resolution vision used for reading, recognizing faces, and driving. Lutein and zeaxanthin filter the high-energy blue light wavelengths that cause the oxidative photo damage, driving macular degeneration. They are physically present in the macular pigment. They are the substance of the eye's natural protection. A clinical trial published in the British Journal of Ophthalmology found lutein supplementation significantly increased macular pigment optical density and improved contrast sensitivity in patients with early macular degeneration. Calendula flowers are among the richest dietary sources of lutein and zeaxanthin in the entire plant kingdom. The monasteries that grew calendula in every healing garden were delivering the macular protective pigments that modern ophthalmology identifies as the primary nutritional defense against the age-related blindness affecting millions. Think of it as the orange flower that medieval healers placed at every eye complaint. That modern ophthalmology has confirmed contains the exact pigments that protect the most critical zone of the retina from light-induced damage. Fennel. Fennel appears in the ancient medical literature of Egypt, Greece, Rome, and the biblical Near East as a specific medicine for the eyes. Dioscorides, the first-century Greek physician who wrote the most comprehensive ancient herbal text, prescribed fennel specifically for improving vision and reducing eye inflammation. Pliny the Elder noted that snakes ate wild fennel after shedding their skin, and that this was the source of the ancient belief that fennel restored acuity of vision. Modern research on fennel and vision is specific and compelling. Fennel seed extract has been shown to reduce intraocular pressure in animal studies through mechanisms that involve enhanced aqueous humor drainage. Intraocular pressure elevation is the primary driver of optic nerve damage in glaucoma. Fennel also contains transanethol, a compound that inhibits the NF-κB inflammatory pathway in retinal tissue, reducing the chronic low-grade retinal inflammation that underlies both macular degeneration and diabetic retinopathy. The ancient world that prescribed fennel for the eyes wasn't guessing. It was observing results across centuries of use in populations that couldn't afford to be wrong about their medicine. Think of it as the plant that Dioscorides prescribed for vision 2,000 years ago, that modern ophthalmological research is confirming reduces the intraocular pressure and retinal inflammation that end vision in aging eyes. Moringa, the miracle tree, known across the ancient civilizations surrounding the biblical world under different names, but recognized universally for one property above all others: extraordinary nutritional density that sustained the body when other food sources failed. Moringa contains lutein, zeaxanthin, and beta-carotene in concentrations that rival any food source ever analyzed. But its most remarkable ocular nutrient is isothiocyanate, specifically Moringa isothiocyanate, which activates NRF2 in retinal pigment epithelium cells. The retinal pigment epithelium is the layer of cells directly beneath the photoreceptors that keeps them alive, removes their metabolic waste, and protects them from oxidative damage. When the RPE fails, the photoreceptors die. This is the precise cellular mechanism of geographic atrophy, the advanced form of macular degeneration that causes central vision loss with no reversible treatment available. A study published in Molecular Vision confirmed Moringa isothiocyanate significantly protected RPE cells from the oxidative stress that triggers their death in macular degeneration pathology. Think of it as the miracle tree of the ancient world that surrounded biblical civilization, that molecular ophthalmology has confirmed protects the specific cells whose death causes the permanent central vision loss affecting millions. Bilberry again, but this time with flaxseed, because the clinical research on vision makes clear that no single plant works in isolation. The combination of anthocyanins from bilberry with the omega-3 fatty acids from flaxseed represents one of the most comprehensively studied nutritional pairings for eye health in clinical ophthalmology. Flaxseed is the plant that clothed the high priest of Israel. Exodus 28 verse 39. The white linen tunic woven from flax, and the seeds that produced that linen were consumed daily across the ancient Near East as food. DHA is the dominant structural fatty acid in photoreceptor cell membranes. The retina contains the highest concentration of DHA of any tissue in the human body. When DHA is chronically insufficient, photoreceptor membrane fluidity decreases, phototransduction efficiency falls, and the photoreceptors become more vulnerable to oxidative damage. Alpha-linolenic acid from flaxseed is the plant-based precursor to DHA. A clinical trial in patients with dry eye disease found flaxseed oil supplementation significantly reduced dry eye symptoms, corneal damage scores, and inflammatory markers in the lacrimal gland. Think of it as the seed that clothed the most sacred office in Israelite worship, that modern retinal biochemistry has confirmed delivers the fatty acid that makes up the physical structure of the cells that produce human vision. Now we are halfway through this list. And if you're starting to understand that vision loss is not inevitable, that it is the predictable consequence of removing from a modern diet the specific compounds that protected the eyes of the ancient world for thousands of years, hit the like button right now. That is exactly what this channel exists to show you. Let's keep going because what comes next is extraordinary. Black currant, Ribes nigrum, a small dark berry of European and Near Eastern forest edges that has been consumed as food and medicine across the ancient world for as long as people have lived in its range. In Japanese ophthalmology research, which is among the most advanced in the world for nutritional eye medicine, black currant has been studied more intensively than almost any other single berry. Anthocyanins from black currant, specifically delphinidin, 3, retinoside and cyanidin, 3, retinoside, are now confirmed by multiple randomized trials to improve blood flow in the retinal microvasculature. A randomized, double-blind, placebo-controlled trial published in Ophthalmologica found black currant extract significantly improved the visual field in patients with normal tension glaucoma, a condition driven by poor retinal blood flow rather than elevated intraocular pressure. The same trial found significant reduction in the visual field deterioration rate compared to placebo over 2 years. 2 years. Slower progression of glaucoma damage. Through a berry. Think of it as the dark berry of the ancient forest edges that Japanese ophthalmological research has confirmed slows the progression of glaucoma through the same retinal blood flow mechanism that the disease destroys. And here we are at number 11. The one I told you about at the very beginning. The one found in virtually every excavated biblical-era food storage site. The one whose randomized trial showed a 43% reduction in macular degeneration progression. Lutein-rich dark leafy greens, specifically the kale, chard, and spinach of the ancient world. The biblical equivalent was a category, not a single plant. Dark bitter leafy greens, consumed at every meal throughout the ancient Near East. Purslane, mallow, endive, chicory, and the bitter herbs of the Passover table. Consumed in quantities that modern populations consuming iceberg lettuce cannot approach. These plants are the richest dietary sources of lutein and zeaxanthin on Earth. Not supplements. The whole leaf, with the fat-soluble carotenoids delivered alongside the dietary fats in the meal that made them bioavailable. The ARDS 2 trial, the Age-Related Eye Disease Study 2, is one of the largest and most rigorous clinical trials in the history of ophthalmology. Over 4,000 patients. Multiple years. The addition of lutein and zeaxanthin to the ARDS supplement formula reduced progression to advanced macular degeneration by 26% compared to the original formula without them. And the participants with the lowest dietary lutein intake at baseline showed the greatest benefit, a 43% reduction in progression, because their dietary deficiency was the largest gap. The biblical world ate dark greens at every meal, not as a side dish, as a central component of every meal. They were delivering the macular protective pigments continuously across a lifetime in food form, at every meal, without exception. Think of it as the bitter greens of the Passover table and the daily biblical meal that the largest clinical trial in the history of ophthalmology has confirmed was protecting the macula with every leaf consumed. Amla, Indian gooseberry, Philanthus emblica, a small sour fruit native to South Asia that traveled the Silk Road into the ancient Near East, arriving in the world of biblical civilization through the trade routes that brought every major plant medicine of the ancient world into contact with Israel, Persia, and Egypt. Amla is the richest plant source of vitamin C ever measured. Per gram, fresh amla contains 20 times more vitamin C than fresh orange. And vitamin C is not a peripheral nutrient for eye health. It is present in the aqueous humor of the eye at concentrations 20 times higher than in blood plasma, because the eye requires concentrated vitamin C to neutralize the oxidative stress generated by continuous light exposure. Clinical research confirms that people with the highest vitamin C intake have significantly lower rates of cataracts, the clouding of the eye's lens driven by accumulated oxidative damage. A prospective study published in Ophthalmology found that the highest tertile of vitamin C intake was associated with a 33% lower risk of cataract progression over a 10-year period. Amla also contains specific tannins and gallic acid that independently protect retinal cells from the UV-induced oxidative damage that the ancient world received in far greater daily doses than most modern populations. Think of it as the most vitamin C-dense food on Earth that traveled the Silk Road into the ancient world, that prospective research has confirmed reduces the risk of the lens clouding that robs sharp vision from aging eyes. Sea Buckthorn. Hippophae rhamnoids, a thorn shrub of Himalayan and Central Asian origin that was traded westward through the ancient Persian and Near Eastern world, and was well known in the Ayurvedic and Persian medical traditions that shared territory and knowledge with biblical civilization. Sea buckthorn berries contain the only known dietary source of palmitoleic acid in significant concentrations. Palmitoleic acid is an omega-7 fatty acid that specifically supports the health of mucous membranes, including the conjunctiva and the tear film that covers the cornea. Dry eye syndrome, the chronic condition affecting over 16 million Americans, is partly a palmitoleic acid deficiency disease in its nutritional dimension. A randomized control trial found sea buckthorn oil supplementation significantly reduced dry eye symptoms and increased tear film stability compared to placebo. Sea buckthorn also contains astaxanthin, the most potent antioxidant carotenoid ever measured in any natural source, at concentrations that protect retinal tissue from the phototoxic damage that accumulates across a lifetime of sunlight exposure. Think of it as the thorn shrub of the ancient Silk Road world that modern dry eye research has confirmed delivers the specific fatty acid that keeps the tear film intact and the cornea protected. Triphala, the three-fruit preparation of Ayurvedic medicine that has been consumed across South Asia and through the Silk Road trade routes touching the biblical world for over 2,000 years. Amalaki, bibitaki, and haritaki, three fruits combined into a single preparation that traditional healers across the ancient world prescribed specifically for maintaining the clarity of vision into old age. Modern ophthalmological research has confirmed what those healers observed. A study published in the Journal of Ocular Pharmacology and Therapeutics found Triphala eye drops significantly reduced intraocular pressure in glaucoma patients. A separate laboratory study confirmed Triphala extract protected retinal ganglion cells, the neurons that carry visual information from the retina to the brain from the oxidative stress that kills them in glaucoma. The gallic acid, chebulagic acid, and chebulinic acid in Triphala are among the most potent antioxidants ever measured in the specific context of retinal tissue protection. The ancient physicians who prescribed Triphala for the eyes across 2,000 years of continuous use were documenting something real. Modern ophthalmology is now measuring exactly what it was. Think of it as the three-fruit preparation of the ancient world's most sophisticated medical tradition that modern glaucoma research has confirmed protects the retinal neurons that carry vision to the brain. Turmeric, specifically for the eye. Turmeric has appeared on previous lists in this channel for its effects on inflammation, the brain, and the cardiovascular system. But its specific role in ocular health deserves its own entry here because the mechanism is distinct. Curcumin in turmeric specifically reduces the expression of VEGF, vascular endothelial growth factor, in retinal tissue. VEGF is the protein responsible for the abnormal blood vessel growth that causes wet macular degeneration and diabetic retinopathy, the two leading causes of blindness in adults with diabetes. The pharmaceutical drugs currently approved for wet macular degeneration, ranibizumab, bevacizumab, aflibercept, all work by blocking VEGF. They are injected into the eyeball every 4 to 8 weeks. They cost thousands of dollars per injection. Curcumin inhibits VEGF through a different but complementary pathway. Laboratory studies confirm the effect in retinal tissue specifically. Clinical trials examining curcumin for diabetic retinopathy are currently underway at multiple research centers. The ancient spice trade that carried turmeric into the biblical world was delivering a compound that targets the same molecular pathway that the most expensive eye injections in modern medicine are designed to block. Think of it as the golden root of the ancient spice routes, whose primary compound targets the exact protein that the most expensive treatments for blindness in the developed world are designed to stop. Green tea for the retina. Camellia sinensis traveled the Silk Road into the ancient Near East and was part of the botanical pharmacopoeia of every civilization along those routes. And for eye health specifically, green tea has a property that almost no other plant shares. EGCG from green tea is one of the very few dietary antioxidant compounds that crosses the blood-retina barrier and accumulates in retinal tissue after oral consumption. A study using animal models found that after oral green tea consumption, EGCG was detected in the retina, lens, and vitreous humor at concentrations sufficient to reduce oxidative stress in photoreceptors. The retinal levels were measurable for up to 20 hours after a single dose. A clinical study found regular green tea consumption significantly associated with lower rates of glaucoma in a large population cohort, an effect specifically attributed to EGCG's ability to protect retinal ganglion cells from the oxidative death that occurs in glaucomatous degeneration. Think of it as the ancient trade route tea whose primary compound crosses the blood-retina barrier and sits in your photoreceptors for 20 hours after every cup, protecting them from the oxidative damage that ends vision. Ginkgo biloba for ocular blood flow, the oldest living tree species on Earth, present in the ancient botanical world of every Silk Road civilization. And for eye health specifically, Ginkgo does something no other plant on this list achieves with the same clinical consistency. It improves blood flow in the optic nerve and the retinal microvasculature through mechanisms involving platelet aggregation inhibition and nitric oxide-mediated vasodilation. The optic nerve is among the most metabolically demanding tissues in the human body. It requires uninterrupted blood supply to function. When that supply is compromised by glaucoma, by cardiovascular disease, by the arterial stiffening of aging, the ganglion cell axons that form the optic nerve begin to die. A randomized controlled trial found Ginkgo extract significantly improved visual field performance in patients with normal tension glaucoma. A separate systematic review confirmed Ginkgo biloba's consistent effect on retinal and optic nerve blood flow across multiple clinical populations. Think of it as the oldest tree on Earth that clinical research has confirmed increases the blood flow to the optic nerve and retina that keeps visual neurons alive when aging tries to starve them. Astaxanthin, the most potent antioxidant ever measured in any natural source, produced by microalgae and concentrated in the marine food chain, present in the ancient diets of every coastal civilization that formed the world of biblical culture. Astaxanthin crosses the blood-brain barrier and the blood-retina barrier. It accumulates in photoreceptor cells and the retinal pigment epithelium, where it provides antioxidant protection with a potency 6,000 times greater than vitamin C and 800 times greater than CoQ10 in specific lipid peroxidation assays. A randomized double-blind placebo-controlled trial found astaxanthin supplementation significantly improved visual acuity, reduced eye fatigue, and improved the ability to focus after 2 months. Another trial found significant improvements in retinal blood flow and reduction in retinal edema in patients with diabetic retinopathy. The coastal populations of the ancient Mediterranean and Near Eastern world who ate small oily fish, shellfish, and marine algae daily were delivering astaxanthin to their retinas continuously across entire lifetimes. Think of it as the compound that makes salmon pink and flamingos red. That is the most potent natural antioxidant ever measured, and that multiple clinical trials have confirmed protects and restores retinal function in the aging eye. And here we are at plant 20. Not a single plant. The practice. The daily habit that connected every plant on this list into the system that actually produced the extraordinary eye health the ancient world maintained across entire lifetimes. Eating all of these plants together as food every single day. Because the clinical research on eye health arrives consistently at the same conclusion. Isolated nutrients, even the ones confirmed in randomized trials, do not produce the same effect as the whole food matrix from which they come. Lutein from a supplement does not behave identically to lutein consumed inside a dark green leaf alongside the dietary fat that makes it bioavailable. Bilberry anthocyanins in isolation do not replicate the combined anthocyanin profile of the whole berry consumed with its fiber and synergistic polyphenol. The ancient world that maintained extraordinary vision into extreme old age was not supplementing. It was eating. Every meal contained dark greens. Every meal contained color. Every meal contained bitterness that signaled phytochemical density. Every meal contained the fats that made the fat-soluble carotenoids absorbable. The vision crisis of the modern world. Macular degeneration affecting 11 million Americans, glaucoma affecting 3 million more, cataracts the leading cause of correctable blindness worldwide, is not a genetic inevitability. It is the predictable consequence of removing from the modern diet the specific foods that protected the eyes of the ancient world at every meal of every day. Your eyes were designed to see clearly into old age. The plants that made that possible have always been here. They're waiting to get back onto your plate. Think of it as the daily food practice that the biblical world never separated from the act of living, that modern nutritional ophthalmology has confirmed was the most effective eye protection system ever developed. 20 plants, 2 eyes. In an ancient world that read scrolls by lamplight into their 80s without the glasses, drops, or injections that the modern world depends on. Smash that like button if this list is changing how you see your food. Drop a comment telling me which plant you are starting with. Are you reaching for the bilberry that helped pilots see in the dark? The saffron that performed in a clinical trial against macular degeneration? The dark greens that the largest eye health study in history confirmed reduced progression by 43%? I read every comment. Subscribe if you haven't yet. We post every week. Because the instruction to see clearly was never only spiritual. And the plans to make it possible have been growing in the fields of the biblical world since long before anyone needed glasses to read them.